everyone, and welcome to another episode of Investigation. In today's episode of Investigation, I will go over natural logarithm derivative, which is basically ln of x that we've seen a little bit in the previous video. And to get started, we will start with a simple little starting problem for today. And that is e to the x. We want to find the derivative of that. So the derivative of that. And notice this is not it is not e to the x. It is rather e to the x power. So there's an invisible parentheses over here. And pause the video if you want to try this problem, and proceed the video when you feel like you're ready. And this problem, we're going to use the chain rule again. As you can see, the chain rule is very, very helpful over here. We can define, if you can't see immediately what is the inside function, what is the outside function, we can define f of x as e of x. Obviously, we're going to use this over here because we know the derivative of e of x, and we can see some e of x over here. But over here, we're actually going to construct a composite function, g of x, that is still e of x. I guess you can combine those equations like that if you don't want to use too many variables. So that is, this function is basically f of x. Why is that? Because this is basically f of x is e to the x, and that is e to the x slot, which is this thing, so e to the x. So we have over here is actually f of x, and if we recall the chain rule, that would just simply be equal to the derivative with respect of e to the x. We don't want to write it this way because it's kind of ambiguous. We can just do this. So the derivative with respect of e to x, which is just this, because the derivative of e to the x is still e to the x. So that times the derivative with respect of x of e to the x. And obviously that is still e to the x. So that's e to the x times e to the x. It's really not that bad, and it's pretty clean compared to the previous daily problems. And obviously, if you want to write it this way, well, yes, you can write it this way. They're equivalent, but this is not simplified a lot, in my opinion. And let's get started with our natural logarithm derivative. Want to find the derivative with respect of x of ln of x. So this thing, how do you find the derivative of that? Well, first, let's just start with simple definition of derivative. That is equal to the limit as h approaches 0 of ln of x plus h minus ln of x over h. And obviously we can use the property of logarithm over here, so that would turn into the limit as h approaches 0 of this ln of x plus h over x over h. And we can get that h out, so basically we can get that h over here so that it becomes a power. So h 1 over h times this ln function, and we can put the 1 over n h inside the ln function to get that is the limit as h approaches 0 of ln of this inside x plus h over x to the 1 over h power, using the property of logarithm. And now we need another substitution. So what substitution fits over here? We know that we have some sort of fractions dealing with x and h. We can just let n is equal to h over x. then we can have that, so that is h is equal to n times x, just multiplying by x on both sides, and we can have that 1 over h. So if we take the reciprocal, that will be 1 over h is equal to 1 over n times 1 over x. And we have, over here, we can substitute everything in. We can have that this is equal to the limit as h approaches 0 of ln of x plus h. So that's just 1 plus h over x, right? 1 plus h over x, and we've defined h over x as n. So that is just equal to 1 plus n to the, that is 1 minus n times 1 minus x power. So that's 1 minus h, 1 over h. So that is equal to 1 over n times 1 over x power, like that. And as we know that as h approaches 0, so as the numerator approaches 0, so that's equal to 0 over something, then our other side, so our fraction will approach 0 as well. So we can just substitute this h to be n. So that is equal to the limit as n approaches 0 times this stuff. We can rewrite this as this to the 1 over n, that to the 1 over x power. And you'll see why we write that in a moment. And we can reverse that step that we did over here. Reverse this step. We can get that 1 over x to be in front. So that will be times 1 over x. And since 1 over x does not have any relations with n, we can just get it out of limits even. So that's 1 over x. And that's times ln of 1 plus n to the 1 over n power. And something like that. And we can put that limit into the logarithmic function. So put that limit inside. So something like this times the ln of the limit as n approaches 0 of this. And we've seen that this is just an expression of e, right? So we can rewrite this as 1 over x times ln of e. And we know that that's just 1, so our final answer is just 1 over x. Thank you for watching this episode of Interstigation, and I will see you in the next one, where we go over a derivative of a random base, so a to the x, not just natural base, not just e. And that's it for today's episode. Goodbye.